Welcome. You have nowhere to be right now and nothing that needs doing. Let your body settle into wherever you are resting and allow your breath to slow, just a little. Tonight, we are going to drift together through one of the most beautiful and peaceful subjects the night sky has to offer, our nearest galactic neighbor, the great Andromeda galaxy. Simply let the words wash over you and rest. Andromeda is the nearest large galaxy to our own Milky Way. Of all the vast island universes scattered across the cosmos, Andromeda is the one that sits closest to our own galactic home. It is our neighbor in the truest sense of the word, immense, ancient, and quietly present in the sky above us every night. Knowing it is there, so near in cosmic terms, brings a gentle kind of comfort. Andromeda is visible to the naked eye on dark, clear nights. You do not need any special equipment, no telescope, no binoculars, nothing at all. On a night far from city lights, when the sky is truly dark and the air is clear, you can look up and see Andromeda with your own eyes, just as human beings have done for thousands of years before us. That quiet continuity is something worth holding gently in the mind. Through the naked eye, Andromeda appears as a faint smudge of light in the night sky. It does not blaze or dazzle. It is subtle and quiet, a soft, pale oval haze, barely brighter than the darkness surrounding it. And yet within that gentle smudge lies over 1 trillion stars. The universe has a way of hiding its greatest wonders in the most understated places, and Andromeda is a perfect example of that quiet generosity. Andromeda is located in the constellation Andromeda, which graces the autumn sky of the northern hemisphere. The constellation itself is a graceful chain of stars, and the galaxy sits just at its northern edge, as if resting quietly against the border of the sky. Finding the constellation is a gentle act of navigation, following the familiar square of Pegasus, then drifting your gaze upward until that soft smudge of light appears. The galaxy is named after the mythological princess Andromeda, a figure from ancient Greek legend. In the old stories, she was a princess of great beauty, placed among the stars by the gods after her tale was told. There is something quietly poetic about that. A galaxy of 1 trillion suns carrying the name of a human figure from an ancient story, connecting the very largest scales of the cosmos to the most intimate human impulse to tell tales and find meaning in the sky. Ancient Persian astronomers recorded Andromeda as early as 964 in the Common Era, long before modern telescopes, long before the word galaxy even existed. Careful observers in Persia were noting this soft patch of light and writing it down. They called it a little cloud among the stars. That description, so simple and so accurate, has echoed across more than 1,000 years. The sky has always been a place of patient, careful watching. Abd al-Rahman al-Sufi described Andromeda in his celebrated book of Fixed Stars, one of the most important astronomical works of the medieval world. Al-Sufi was a meticulous and gifted observer, and his careful description of Andromeda as a small cloud is the earliest known written record of any galaxy beyond our own. His work was a bridge between the ancient sky watchers and the astronomers who would come centuries later, all of them looking up at the same soft light. Andromeda is catalogued as Messier 31 in the famous list compiled by the French astronomer Charles Messier in the 18th century. Messier was searching for comets, and he created his catalogue of fuzzy sky objects simply to avoid confusing them with the comets he was hunting. Andromeda was number 31 on that list, a practical note in a working astronomer's journal that has since become one of the most recognized designations in all of astronomy. Andromeda sits roughly 2,537,000 light-years from Earth. That number is almost impossible to hold in the mind, and perhaps that is all right. A light year is the distance light travels in a full year, moving at nearly 300,000 kilometers every single second, and Andromeda is more than 2.5 million of those years away. The light entering your eyes on a clear night left that galaxy long before our earliest human ancestors walked the Earth. Let yourself settle now, just a little more deeply. Feel the weight of your body resting where you are, and let that weight be held completely. There is nothing to figure out tonight, nothing to remember, nothing to do. Each breath you take is slower and softer than the last. Let your thoughts drift the way clouds drift, gently, without effort, without direction. You are safe, you are still, and the night is quiet all around you. The light we see from Andromeda tonight left that galaxy more than 2.5 million years ago. It has been traveling through the darkness of space ever since, crossing an almost unimaginable distance, and it arrives quietly at your eye on a clear night. When that light began its journey, our earliest human ancestors were just appearing on Earth. The galaxy you see is not Andromeda as it is Andromeda as it was, a portrait painted in ancient light. Andromeda spans about 220,000 light-years in diameter. Our own Milky Way is roughly 100,000 light-years across, making Andromeda more than twice as wide. To cross Andromeda at the speed of light would take longer than our entire solar system has existed. It is a structure of breathtaking scale, and yet from here it appears as nothing more than a soft, gentle smudge, a whisper of light pressed gently into the dark. Andromeda contains an estimated 1 trillion stars. That is 1 followed by 12 zeros, a number so vast it dissolves into pure wonder. If you tried to count them one per second, it would take longer than the current age of the universe. Each of those stars is a sun, many of them ancient and cool, some young and blazing, countless others somewhere in between. All of them gathered together in one slow, turning structure, drifting gently through the dark. By comparison, our own Milky Way contains roughly 200 to 400 billion stars. That is still a number beyond easy imagining, and yet it is somewhere between 1/4 of Andromeda's stellar population. We live inside one of the universe's grand spirals, but Andromeda is grander still. 2 great cities of stars, neighbors across the dark, each one holding within it billions of quiet suns. Andromeda is a spiral galaxy, classified by astronomers as Typsa Open SB. That classification is a quiet shorthand for its shape and structure, a grand, sweeping spiral with loosely wound arms and a prominent central bulge. Astronomers have spent generations building careful systems for describing the shapes of galaxies, and Andromeda fits beautifully into one of the most graceful categories. It is, in the language of science, a classic spiral. Andromeda's spiral arms wrap gracefully around a bright central bulge, curving outward in long, sweeping arcs. Within those arms, stars are born and age and eventually fade, and dust and gas drift in slow currents between them. The arms are not rigid structures. They are more like gentle waves moving through a sea of stars, patterns of density that travel slowly through the disk. It is a kind of beauty that unfolds over millions of years. Andromeda's central bulge is visibly elongated rather than perfectly round. When astronomers examine the heart of the galaxy closely, they find it is not a smooth sphere of stars, but rather a slightly stretched, bar-like shape. This elongation is a clue, written into the structure of the galaxy itself, a record of the forces and history that shaped it over billions of years. Even the center of something so vast holds its own quiet secrets. Andromeda is tilted about 77 degrees relative to our line of sight. Imagine holding a great spinning disk and tipping it nearly edge, on toward you. That is roughly how we see Andromeda from Earth. We are not looking down at it from above, the way we might imagine a galaxy in an illustration. We are gazing at it from a steep angle, almost from the side, which changes everything about how it appears to us. Because of this steep tilt, Andromeda appears from Earth not as a full face, on spiral, but as an elongated oval of soft light. The round disk, seen at such an angle, is compressed by perspective into a long, gentle ellipse. It is the same effect as looking at a circular plate from the side. The circle becomes a slender shape. That soft oval glow, stretched quietly across the dark sky, is how most of us will ever know Andromeda. Andromeda's apparent size in the sky is about 6 times the width of the full moon. That is a remarkable thing to sit with quietly. The full moon already feels generous and wide as it rises above the horizon, and yet Andromeda, if our eyes were sensitive enough to take it all in, would spread across 6 full moon widths of sky. It is an enormous presence hanging silently above us every clear night, vast and unhurried, asking nothing of us at all. Let your body settle a little more deeply now. Feel the weight of your limbs, the softness of the surface beneath you. There is nothing to hold on to tonight, nothing to figure out or remember. Each breath comes and goes on its own, slow and easy. Let your thoughts thin out, like mist drifting across still water, growing lighter and lighter. You are safe, you are warm, and there is nowhere else you need to be. Despite its large apparent size in the sky, only Andromeda's core is bright enough to see with the unaided eye. The outer spiral arms and the wide halo of stars that surround the galaxy are simply too faint for our eyes to gather in the darkness. What we see on a clear, dark night is just the innermost heart of the galaxy, a soft, concentrated glow, like the ember at the center of a dying fire, the rest of its vast body invisible around it. Andromeda's total angular span covers roughly 3 degrees of sky. Astronomers measure the apparent sizes of objects in degrees, and 3 degrees is a generous stretch of the heavens. For comparison, the full moon covers just half a degree, so the full reach of Andromeda, from one edge of its halo to the other, spans the equivalent of 6 full moons placed side by side in a quiet row across the night. Most of that span is invisible, but it is there, patient and immense. The galaxy glows at an apparent magnitude of about 3.44. In astronomy, magnitude is a measure of brightness as seen from Earth, and lower numbers mean brighter objects. At 3.44, Andromeda sits comfortably within the range of stars visible on a clear night, just faint enough to need dark skies and a moment of patience. It is not a blazing light, but a soft, steady presence, the kind of glow that rewards those who slow down and look. Andromeda is the most distant object visible to the unaided human eye. Everything else we can see in the night sky without a telescope, every star, every planet, every nebula, lies within our own galaxy. But Andromeda sits 2.5 million light-years away, in another galaxy entirely, and still our eyes can find it. It is perhaps the most humbling thing our vision is capable of, reaching across intergalactic space with nothing more than the quiet biology of sight. Binoculars reveal Andromeda's oval glow and hint of its dust lanes. With even a modest pair of binoculars held steady against the dark sky, the galaxy opens up a little more. The soft smudge becomes a clearer oval, a gentle lens of light with a brighter center fading outward. And if the night is very dark and the binoculars are held very still, faint suggestions of darker lanes begin to appear, thin shadows threading through the glow, the first whisper of Andromeda's hidden structure. A small telescope shows Andromeda's bright nucleus and surrounding haze. Through a modest backyard telescope, the galaxy reveals a new layer of itself. The core brightens into a distinct, concentrated point of warm light, surrounded by a softly glowing haze that spreads outward in all directions. It is like watching a lantern behind frosted glass. The light is real and present, but still veiled, still gentle. The telescope brings you closer, without ever fully lifting the mystery. Large telescopes reveal the galaxy's intricate dust lanes and spiral structure. When more powerful instruments are turned toward Andromeda, the galaxy unfolds in breathtaking detail. Long, dark dust lanes curve through the disk like brushstrokes, absorbing the light behind them and tracing the shapes of the spiral arms. Regions of warmer and cooler light emerge, each telling a small part of the galaxy's long story. What once appeared as a faint smudge becomes a world of extraordinary complexity, still quiet, still beautiful. Andromeda moves toward the Milky Way at roughly 110 kilometers per second. That is an extraordinary speed by any earthly measure, and yet on the scale of the cosmos, it is almost imperceptibly slow. At that pace, Andromeda will not reach us for billions of years. There is no urgency in its approach, no rush or alarm. It simply drifts closer, year by year, century by century, the way two clouds might slowly drift together across a very wide and very peaceful sky. This approach speed makes Andromeda one of the few blue-shifted galaxies in the known universe. Almost everything in the cosmos is moving away from us, carried outward by the expansion of space itself. But Andromeda is different. It is one of a small and quiet handful of galaxies that moves closer rather than farther. Its light arrives compressed, shifted ever so slightly toward the blue end of the spectrum, a gentle signature of something drawing near across the dark. Most galaxies show redshift because the universe is expanding away from us. Space itself is stretching in all directions, and the light from distant galaxies stretches with it, shifting toward the red end of the spectrum like the fading note of a sound moving away. It is one of the quietest and most profound discoveries in all of science that the universe is not still, but gently, endlessly expanding, carrying most of its galaxies outward into the deep. Let your body settle a little more deeply now. If there is any tension left in your shoulders, let it release. If your thoughts are still moving, let them slow, like water finding its way to stillness. There is nothing to hold on to right now, nothing to figure out. Just this quiet moment, this soft darkness, and the gentle rise and fall of your own breathing. You are exactly where you need to be. Let yourself drift. Andromeda's blue shift was first measured by Vesto Slipher in 1912. Working at the Lowell Observatory in Arizona, Slipher turned a spectrograph toward the faint smudge of light and recorded something no one had seen before. Light arriving slightly compressed, shifted toward the blue. He was a quiet, methodical man, and this quiet, methodical observation would eventually help reshape our understanding of the entire universe. The measurement took time and patience, like so much of the best science does. Edwin Hubble used Cepheid variable stars to determine Andromeda's distance in 1923. Cepheid stars are remarkable. They pulse in brightness with a steady, reliable rhythm, and that rhythm reveals their true luminosity. By comparing how bright they appear to how bright they truly are, Hubble could calculate exactly how far away they must be. It was like knowing the true brightness of a distant lamp, and using that knowledge to measure the length of a very long, very dark hallway. Hubble's measurement proved that Andromeda lay far beyond our own galaxy. Before his work, many astronomers believed the faint spiral nebulae were simply clouds of gas within the Milky Way itself. Hubble's careful calculation showed that Andromeda was not nearby at all. It was unimaginably distant, far outside any boundary our galaxy could claim. The universe, it turned out, was vastly larger than anyone had dared to imagine. And that realization arrived not with a shock, but with a slow, quiet wonder. This discovery confirmed that the Milky Way is just one of many galaxies in the universe. Our home, which had seemed so vast and complete, was revealed to be simply one island of stars among countless others. It was a humbling and beautiful moment in human understanding, not frightening, but freeing. The cosmos opened outward in every direction, filled with other galaxies drifting in the dark, each one a world of its own, each one quietly shining across distances beyond easy imagining. Andromeda and the Milky Way are the two largest members of the local group. Like two great neighbors sharing a quiet stretch of cosmic countryside, they anchor the collection of galaxies that surrounds us. Each is enormous in its own right, vast spirals of hundreds of billions of stars, wrapped in dark matter halos stretching far beyond their visible edges. Together, they form the gravitational heart of a small but rich community of galaxies, bound gently to one another across the dark. The local group contains more than 50 galaxies bound together by gravity. Most of them are small and faint, dwarf galaxies, irregular in shape, scattered quietly around the two great spirals at the center. Some are barely more than loose collections of ancient stars, drifting slowly through the dark. But gravity holds them all together, the way a gentle field holds wildflowers, not tightly, not forcefully, but with a persistent, patient pull that keeps the whole group moving as one through the larger cosmos. Andromeda dominates one side of the local group, while the Milky Way dominates the other. Between them lies a quieter middle ground, populated by smaller companions and wandering dwarf galaxies. It is a balanced arrangement, almost like two great trees growing at either end of a long meadow, their branches reaching toward each other without yet touching. Each holds its satellites close, shapes the space around it, and slowly, over billions of years, draws nearer to the other across the peaceful dark. Andromeda has at least 19 known satellite dwarf galaxies orbiting it. Circling the great spiral like quiet moons around a planet, these small companions trace slow paths through the dark, held close by Andromeda's patient gravity. Each one is a galaxy in its own right, a collection of ancient stars, faint and unhurried. Together they form a gentle family around their larger host, drifting in wide, graceful arcs through the soft emptiness beyond the spiral's edge. M32 is a compact elliptical dwarf galaxy orbiting close to Andromeda. It appears as a small, dense knot of soft golden light, nestled near the edge of Andromeda's great disk. Unlike the sweeping spiral arms of its host, M32 is smooth and rounded, a tightly packed gathering of older stars with no visible structure, just a warm, concentrated glow. It orbits close enough that Andromeda's gravity has slowly shaped and compressed it over billions of years. M110 is a larger elliptical dwarf galaxy also orbiting Andromeda. It sits a little farther out than M32, softer and more diffuse, a pale oval haze of stars spread gently across the dark. M110 is one of the brightest of Andromeda's companions, visible even through a small telescope on a clear night. It drifts in a wide, unhurried orbit, a quiet presence in the outer reaches of Andromeda's gravitational embrace. Let yourself rest now, just for a moment. There is nothing to hold on to, nothing to figure out, nothing left to do tonight. Let your breath slow a little more with each exhale, in gently and out slowly. Feel the weight of your body softening into wherever you are resting. The thoughts of the day can drift away like wisps of cloud across a quiet sky. You are safe, you are still, and there is only this gentle darkness and the soft sound of your own breathing carrying you slowly toward sleep. Andromeda the 1st through Andromeda the 35th are catalogued satellite galaxies of Andromeda. Astronomers have named and numbered them carefully, each one a small world discovered through patient observation. They range from tiny clumps of ancient stars to slightly larger systems with their own faint glow. Most are invisible to the naked eye, known only through careful telescope surveys. Yet each carries a name, a quiet acknowledgement that even the smallest, faintest galaxy is worth remembering. Many of Andromeda's satellites are aligned in a thin plane, rather than randomly distributed. Instead of being scattered in every direction as one might expect, a striking number of these small companion galaxies seem to orbit together along a flattened sheet, It is as though they have been arranged along a single gentle arc sweeping through space. Scientists find this pattern remarkable and are still working to understand how such an orderly arrangement came to be around such a vast and ancient galaxy. This planar arrangement of satellites is a puzzle for standard cosmological models. Most simulations of how galaxies form predict that satellite companions should be scattered more or less randomly in all directions around their host. Finding so many aligned in a thin sheet challenges those predictions in a quiet but meaningful way. Scientists believe there may be something about the way Andromeda gathered its companions, perhaps through ancient streams of infalling matter, that shaped this unexpected arrangement over billions of years. Andromeda's halo of stars and gas extends far beyond its visible disk. If you could see it fully, the galaxy would appear far larger than its bright spiral suggests, a vast, almost invisible cloud of ancient stars and tenuous gas billowing outward in every direction. This halo is not empty space. It is filled with the faint traces of Andromeda's long history, stars that were scattered outward long ago, still slowly orbiting, still belonging to the galaxy, even in the outermost dark. The stellar halo of Andromeda reaches out over 2 million light-years. That distance is breathtaking to hold in the mind. 2 million light-years, nearly as far as Andromeda itself is from Earth. The halo stretches in every direction, a vast invisible sphere of ancient light. Most of its stars are old and faint, relics of the galaxy's earliest formation, drifting at the very edge of Andromeda's gravitational reach. It is one of the largest known stellar halos of any galaxy in the local group. Andromeda's halo nearly touches the outer edges of the Milky Way's own halo. Across the vast distance between our two galaxies, these great invisible clouds of stars and gas are already brushing close to one another. In a sense, the two galaxies are already in contact, not at their bright spiral cores, but at their outermost, most tenuous edges. It is a quiet, unhurried meeting, happening across millions of light-years, as the two great neighbors slowly, gently lean toward each other through the dark. Giant stellar streams arc through Andromeda's halo from past galactic mergers. These are rivers of stars, drawn out into long, graceful curves by the pull of gravity over billions of years. They do not move quickly. They drift, slowly, like smoke left behind after something ancient passed through. Each stream traces a path that a smaller galaxy once traveled, pulled apart so gently and so gradually that its stars simply spread into a ribbon of soft light across the dark. The giant southern stream is the most prominent tidal stream around Andromeda. It sweeps outward from the southern regions of the galaxy's halo in a long, luminous arc, the brightest and most clearly defined of all the stellar ribbons that trace Andromeda's past. Astronomers have studied it carefully, mapping its stars and measuring their motions. It tells a story of a galaxy that once existed on its own, wandering through space, until Andromeda's gravity slowly, inevitably, drew it in. These stellar streams are the remnants of smaller galaxies torn apart by Andromeda. Torn apart sounds dramatic, but the process is extraordinarily slow and gentle by any human measure, unfolding over hundreds of millions of years. Gravity simply pulled more strongly on one side of a small galaxy than the other, stretching it gradually, like soft dough, until its stars spread into a long, thin trail. Nothing was sudden, nothing was violent. It was simply the quiet, patient work of gravity across deep time. Andromeda has consumed dozens of smaller galaxies throughout its history. Each one added its stars to Andromeda's growing body, contributing to the halo, the disk, the streams of light that still drift through the outer dark. In this way, Andromeda is not simply a galaxy, it is a gathering. A long, slow accumulation of smaller worlds, each one folded gently into the larger whole over billions of years. What we see tonight in the sky is the sum of all those quiet absorptions. Let your body settle now, just a little more. Feel the weight of your shoulders releasing, the quiet of your hands resting still. There is nothing to hold on to right now, nothing to remember or plan, just the soft darkness around you and the slow, easy rhythm of your own breathing. Let each breath carry you a little further from the day, a little deeper into rest. You are here, you are safe, and the night is long and gentle. Simply drift. Evidence of past mergers is written in shells and ripples of stars around Andromeda. When a smaller galaxy falls into a larger one, the stars do not simply vanish. They settle into faint concentric arcs, like ripples spreading outward after something drops into still water. Astronomers have found these shells in Andromeda's outer regions, ghostly curves of starlight that mark where ancient galaxies once fell. They are quiet records written in light of meetings that happened billions of years ago. Andromeda's disk contains regions of active star formation visible in ultraviolet light. In ordinary visible light, the galaxy appears soft and golden. But shift your view into the ultraviolet, and something different emerges. Bright knots and patches of intense blue-white light, where young, hot, massive stars have recently ignited. These are the newest additions to Andromeda's stellar family, burning brilliantly for a short time before fading. The galaxy is still alive, still building, still quietly making new suns. A prominent ring of star formation sits about 30,000 light-years from Andromeda's center. It is one of the most striking features of the galaxy when viewed in infrared and ultraviolet light. A great glowing ring encircling the core at a vast distance, studded with regions where new stars are being born. 30,000 light-years is an enormous span, and yet this ring traces it completely, like a soft halo of creation drawn around the older, quieter heart of the galaxy. This star-forming ring may have been triggered by a collision with M32 long ago. Scientists believe that M32, that small, compact companion galaxy orbiting close to Andromeda, may once have passed directly through Andromeda's disk like a stone dropped into still water. The impact would have sent a wave of compressed gas rippling outward, and where that wave traveled, new stars began to form. The ring we see today may be the lasting echo of that ancient, gentle collision. Andromeda forms stars at a rate of roughly 1 solar mass per year, 1 new sun's worth of material condensing into stars each year. It sounds modest, and in cosmic terms it is. Andromeda is not a vigorous star-forming galaxy by any measure. It moves at a gentle pace now, a quiet, steady rhythm of creation that has been slowing over time. 1 solar mass per year, year after year, century after century, adding new lights to a galaxy that already holds 1 trillion. The Milky Way forms stars at a higher rate than Andromeda currently does. Our own galaxy, for all that it seems familiar and close, is actually the more active of the 2 great neighbors right now. The Milky Way is thought to form several solar masses of new stars each year, while Andromeda has settled into a quieter pace. It is a gentle reminder that size alone does not determine vitality. Our galaxy, smaller in star count, is presently the more industrious of the pair. Andromeda's star formation rate has been declining over recent cosmic time. Long ago, in the early universe, Andromeda was far more active, blazing with the birth of new stars at a pace we can barely imagine today. But over billions of years, that fire has slowly, gently dimmed. The gas that once fed rapid bursts of creation has been gradually used up or dispersed. Andromeda is not dying, simply aging, settling into a slower, more contemplative rhythm, like a long exhale after a life fully lived. Andromeda contains vast clouds of hydrogen gas that fuel future star birth. Even as its overall rate of formation slows, Andromeda still holds enormous reserves of raw material, great drifting clouds of hydrogen scattered through its disk and spiral arms. These clouds are the nurseries of stars not yet born, the quiet potential of suns still waiting to ignite. They drift through the galaxy in slow, graceful silence, carrying within them the seeds of future light, patient beyond any measure of human time. Dust lanes in Andromeda's spiral arms absorb and redden background starlight. Running through the graceful sweep of Andromeda's arms are dark, curving lanes of cosmic dust, fine particles of carbon and silicate that drift between the stars. These lanes do not glow themselves. Instead, they quietly absorb the light behind them, dimming and reddening it the way Earth's atmosphere reddens the setting sun. From our vantage point, they appear as soft, dark ribbons winding through the galaxy's golden glow, beautiful in their quiet obscurity. Infrared observations reveal warm dust heated by young stars in Andromeda. Where visible light shows us dust as darkness, infrared light tells a different story. When young, hot stars ignite near a dust cloud, they warm the surrounding particles, and that warmth radiates outward as infrared light, a soft, invisible glow that our eyes cannot see but our telescopes can. In infrared, Andromeda's dust lanes transform from dark ribbons into warm, glowing traces of recent star birth, quietly marking the places where new suns have just begun their lives. Let your body grow a little heavier now. Let your shoulders settle. Let your jaw soften. Let your hands rest open and still. There is nothing left to hold onto tonight. Each breath you take is slower and deeper than the last, carrying you gently downward into a quieter place. The thoughts of the day are drifting away like wisps of cloud, dissolving into the dark, and in their place there is only stillness, warm, soft, and wide as the night sky itself. Andromeda has been imaged across the full electromagnetic spectrum. Astronomers have turned instruments of every kind toward our great neighbor: radio telescopes, infrared detectors, visible light cameras, ultraviolet sensors, and X-ray observatories. Each reveals a different layer of the galaxy, a different population of stars or clouds or energetic processes. Together, these views build a portrait far richer than any single image could offer. A galaxy seen in all its dimensions, each wavelength of light adding another quiet voice to the whole. The Spitzer Space Telescope mapped Andromeda's infrared glow in fine detail. Launched in 2003, Spitzer was a telescope sensitive to the warmth of the universe, the gentle heat of dust and cool stars invisible to ordinary eyes. When it turned toward Andromeda, it revealed the galaxy's spiral structure with remarkable clarity, tracing the warm dust lanes and star-forming regions in glowing detail. The resulting image was one of the most detailed infrared portraits of any galaxy, a quiet masterwork of patient observation. The Herschel Space Observatory revealed cold dust throughout Andromeda's disk. Where Spitzer detected warm dust near young stars, the Herschel Observatory, sensitive to even longer wavelengths, found the colder dust scattered more broadly across the galaxy's disk. This cold dust, far from any heating source, glows only faintly, but Herschel could see it clearly. It revealed a galaxy threaded through with cool, quiet material, the raw substance of future stars resting in the dark between the arms, patient and still. NASA's GALAX mission captured Andromeda's ultraviolet glow from hot young stars. The Galaxy Evolution Explorer, known as GALAX, was designed to see the universe in ultraviolet light, the energetic glow of the hottest, youngest stars. When it observed Andromeda, it revealed a galaxy studded with brilliant blue-white points and arcs of ultraviolet light, tracing exactly where the newest stars had recently formed. Against the softer, older glow of the galaxy's ancient stellar population, these young stars shone like sparks, brief and radiant and new. The Chandra X-ray Observatory detected hundreds of X-ray sources within Andromeda. Chandra, a telescope designed to see the universe's most energetic light, turned its gaze toward our great neighbor and found it alive with glowing points of X-ray emission. Hundreds of these sources scattered across the galaxy's disk and halo, each one a place where matter is heated to extreme temperatures. It was a view of Andromeda that no human eye could ever see directly, fierce and beautiful and quietly astonishing. Many of Andromeda's X-ray sources are binary systems containing neutron stars or black holes. In these paired systems, a dense stellar remnant pulls material from a companion star, and as that material spirals inward, it heats to millions of degrees and radiates in X-rays. These are ancient dances between dying stars and their partners, quiet, slow, and immensely powerful. Each glowing point in Chandra's image marks a place where the end of one star's life has become something radiant and enduring. Andromeda hosts over 450 confirmed globular clusters, far more than the Milky Way. These ancient, tightly packed spheres of stars orbit the galaxy like slow and faithful attendants, each one containing hundreds of thousands of stars bound together by gravity. The Milky Way holds perhaps 150 such clusters, but Andromeda's collection is far richer. Scattered through its halo and disk, they are among the oldest structures in the universe, patient, enduring, and deeply still. Andromeda's globular clusters range widely in age and chemical composition. Some are among the oldest objects known, formed in the very early universe when the first generations of stars were lighting up the darkness. Others are younger, richer in heavier elements forged in stellar interiors over billions of years. Together they form a kind of library, each cluster a chapter in the long history of how Andromeda grew and changed, written in the ages and chemistry of its stars. The globular cluster G1 in Andromeda is one of the most massive known globular clusters in the entire local group. It is a vast, dense congregation of stars, containing perhaps 10 million solar masses of material packed into a single glowing sphere. G1 orbits far out in Andromeda's halo, ancient and enormous, larger than nearly any other cluster we know. When astronomers first measured its size and mass, they found it sitting at the very edge of what a globular cluster can be. G1 may harbor an intermediate mass black hole, quietly resting at its center. Astronomers studying the motions of stars within G1 found that the stars near its core move faster than expected, a subtle but telling sign that something very massive and invisible may be pulling on them. Scientists believe this could be a black hole containing perhaps 20,000 solar masses, sitting between the stellar mass black holes and the supermassive giants found in galactic cores. It is a mystery held gently, with wonder rather than alarm. Let your body settle a little more deeply now. If there is any tension still resting in your shoulders, your jaw, your hands, let it soften and release. You have nowhere to be and nothing to do. Each breath carries you a little further from the day, a little closer to rest. The universe is vast and unhurried, and tonight it holds you gently. There is only this quiet, this warmth, this slow and easy drift toward sleep. Andromeda's nucleus contains a double-peaked structure known as P1 and P2. When astronomers looked closely at the very heart of Andromeda, they found something unexpected, not one single bright center, but two distinct concentrations of light sitting close together. These two peaks, named P1 and P2, give Andromeda's nucleus a subtle doubled appearance. It is a quiet structural secret hidden at the core of our nearest large neighbor, invisible to all but the most careful instruments. This double nucleus was discovered by the Hubble Space Telescope in 1993. Before Hubble's sharp eye turned toward Andromeda's core, the two peaks were too close together to resolve from the ground. When Hubble's images came back, astronomers saw the doubled structure for the first time with clarity, a revelation that changed how scientists understood the very center of our neighbor galaxy. It was a quiet discovery, made not with drama, but with patience and precision, the way the best science often is. P1 is a clump of older stars offset from the true center of the galaxy. It is not where the heart of Andromeda actually lies. It is a dense gathering of ancient red stars that happens to sit slightly to one side of the true dynamical center. Scientists believe this cluster of stars may be orbiting the galaxy's actual center in a slow, elongated path, spending more time near one end of its orbit and creating the appearance of a second bright peak. It is a gentle illusion, written in the slow movements of ancient stars. P2 marks the actual dynamical center, where the supermassive black hole resides. While P1 is a bright but offset gathering of old stars, P2 is the true heart of Andromeda, the precise point around which everything in that vast galaxy ultimately turns. It is quieter in appearance than P1, less visually prominent, and yet it is the place where gravity reaches its most concentrated form. Beneath its calm glow, something enormous and ancient holds the center still. Andromeda's central supermassive black hole has a mass of about 100 million solar masses, 100 million times the mass of our own Sun, gathered into a single point of extraordinary gravity at the heart of our nearest large neighbor. And yet from here, across 2.5 million light-years of quiet space, it is entirely invisible, a profound stillness buried within a soft smudge of ancient light. It rests there as it has for billions of years, patient and immense. This makes Andromeda's black hole roughly 25 times more massive than the Milky Way's. Our own galaxy's central black hole, known as Sagittarius, a star, has a mass of about 4 million solar masses, itself almost incomprehensibly large. But Andromeda's is far greater still. A quiet giant sitting at the center of our neighboring spiral, the two galaxies are drawing slowly toward each other, and one day their two immense hearts will meet in the deep stillness of cosmic time. A disk of hot blue stars orbits very close to Andromeda's central black hole, nestled right at the very core of the galaxy, within just a few light-years of that enormous gravitational anchor. A small rotating disk of young blue stars traces tight orbits in the darkness. They are brilliant and hot, burning with the intense blue-white light of youth, circling endlessly in the deep gravity well of the black hole. It is a delicate and surprising kind of beauty, hidden at the center of things. This blue stellar disk was an unexpected discovery made by Hubble in 2005. When astronomers analyzed Hubble's detailed observations of Andromeda's nucleus, they were surprised to find this compact ring of hot young stars so close to the black hole. Conventional understanding suggested such a place would be too turbulent and gravitationally extreme for stars to form or survive. And yet, there they were, calm, bright, and orbiting in quiet defiance of expectation. Science, like the universe, is full of gentle surprises. Andromeda's total mass, including dark matter, is estimated at about 800 billion solar masses. When astronomers account for not just the stars and gas and dust we can see, but also the vast invisible scaffolding of dark matter that surrounds and permeates the galaxy, the total becomes almost impossible to hold in the mind. 800 billion times the mass of our Sun. And yet the galaxy floats in the darkness like a whisper of light, serene and weightless in appearance, its true immensity hidden from view. Some estimates place Andromeda's total mass comparable to, or even less than the Milky Way's. For a long time, scientists assumed Andromeda was the larger of the two great spirals in our local group, the senior partner in a slow gravitational dance. But more recent measurements have suggested The two galaxies may be more evenly matched than once thought, or that our own Milky Way may even be the heavier of the pair. Scientists are still refining these estimates, and the answer rests gently in the realm of ongoing discovery. Let your breath slow a little now. There is nothing to hold on to, nothing to figure out. Let the numbers and the distances and the vast quiet of space simply wash over you like a gentle tide. Feel the weight of your body resting completely, every muscle softening, every thought loosening its grip. The universe has been turning slowly for billions of years, and it will continue long after this peaceful night. You are held, you are safe. Let yourself drift a little further now, easy and unhurried, toward sleep. Dark matter forms a vast invisible halo surrounding Andromeda's visible structure. Beyond the outermost stars, beyond the faint arcs of stellar streams and the dim outer reaches of the disk, there extends a presence that no telescope can directly image, a halo of dark matter stretching hundreds of thousands of light-years in every direction. It neither emits nor reflects light, and yet its gravity shapes everything within the galaxy. It is the quiet architecture beneath the beauty, invisible and essential. The ratio of dark matter to normal matter in Andromeda mirrors the cosmic average. Across the observable universe, scientists believe that ordinary matter, the stars, gas, dust, and everything we can see, makes up only about 1/6 of all the matter that exists. The rest is dark matter, silent and unseen. Andromeda follows this same quiet proportion faithfully, a single galaxy reflecting the deep pattern of the whole cosmos. In this way, our neighbor is not unusual, it is simply a gentle echo of the universe itself. Andromeda and the Milky Way are gravitationally bound and destined to merge. These two great spirals, neighbors across 2.5 million light-years of space, are not simply drifting in the same cosmic neighborhood by chance. Gravity has already written their shared future in the slow, inevitable language of attraction. They have been drawing toward each other for billions of years, and that gentle pull will not relent. Their story, in the deepest sense, is one story, two galaxies already bound together by the oldest force in the universe. Simulations predict the collision will begin in approximately 4.5 billion years. Scientists have run detailed computer models of this future encounter, tracing the paths of billions of stars across vast stretches of time. The number that emerges from these simulations is both enormous and strangely intimate. 4.5 billion years from now, the two galaxies will begin to truly meet. That is a span of time so deep it dissolves quietly into abstraction, like a horizon that never quite arrives, always patient, always unhurried. The merger will likely be complete roughly 6 billion years from now, even after the first gravitational encounter. The full blending of two galaxies is not a swift event. The two great spirals will pass through each other, swing apart, draw back together, and gradually interweave over the course of another 1.5 billion years. 6 billion years is a number that rests beyond imagination, a quiet eternity. And yet it is simply the next chapter in a story already billions of years old, unhurried, immense, and strangely peaceful. During the collision, individual stars are unlikely to physically collide due to vast spacing. It may seem as though two galaxies crashing together would be a catastrophe of unimaginable violence, but the reality is far quieter. Stars are separated by such enormous distances, light-years of empty space between each one, that even as the galaxies pass through each other, the individual stars will almost certainly never touch. The collision is more like two great swarms of fireflies drifting through one another in the dark, each light passing freely through the spaces between all the others. The interstellar gas clouds of both galaxies will collide and trigger bursts of star formation. While the stars themselves pass freely through the encounter, the great clouds of gas and dust that drift between them will not be so unaffected. Gas clouds can collide and compress, and when they do, they can ignite, collapsing inward under their own gravity until new stars are born in sudden, brilliant clusters. The merger will be a time of extraordinary stellar birth, a great flowering of new suns kindled by the slow embrace of two ancient galaxies. The merger will dramatically reshape the spiral structures of both galaxies. The elegant arms that define both the Milky Way and Andromeda as spiral galaxies will not survive the encounter intact. Gravitational forces will stretch and distort them, pulling stars into long tidal streams and arcing bridges of light. The familiar pinwheel shapes will slowly dissolve into something new, a single, broader, more diffuse structure. It is a kind of transformation, not a destruction. Something old giving way, gently and over immense time, to something entirely new. Astronomers have named the resulting merged galaxy Milkomeda, or Milkdromeda. Scientists who study this future collision have given the eventual product of the merger a name, a blending of the two galaxies' names into one, Milkomeda, or sometimes Milkdromeda. There is something quietly lovely about a name like that, a name that holds both histories inside it, that carries the memory of two separate spirals, even as it describes something wholly new. It is a name for a galaxy that does not yet exist, waiting patiently billions of years ahead. Milkomeda will likely be an elliptical or lenticular galaxy with no spiral arms. The galaxy that emerges from the merger will probably bear little resemblance to the graceful spirals that gave it birth. Elliptical galaxies are rounder, smoother, more diffuse, vast clouds of stars with no distinct arms, no sweeping pinwheel structure. The dynamic, star-forming energy of spiral galaxies tends to quiet after such mergers. Milkomeda will likely be a more settled, more ancient-feeling place, serene and immense, its great spiral youth long dissolved into a softer, broader light. Rest here for a moment. There is no need to follow every thought or hold on to any image. Simply let your breath move slowly in and out. Each exhale a little longer, a little softer. Feel the gentle weight of your body, the warmth of wherever you are resting. The vast, slow turning of galaxies continues without any effort from you. You do not need to do anything at all. Just let the quiet of deep space settle around you, like a soft blanket, and allow yourself to drift a little further, gently and easily, toward sleep. Our solar system may be flung to a very different location in the merged galaxy. During the turbulent gravitational dance of the merger, the orbits of stars within both galaxies will be dramatically disrupted. Our own sun, along with the entire solar system, could find itself carried far from its current position, perhaps to the outer reaches of the new combined galaxy, or to some entirely unfamiliar region of Milkomeda. It is a strange and gentle thought that our cosmic address may one day be something altogether different, written in the new geography of a galaxy not yet born. The night sky during the merger will be dramatically brighter, with new stars and structure. As the two galaxies begin to interweave, the sky, as seen from any surviving world, would transform into something almost unimaginably rich. Vast rivers of newborn stars would arc overhead, glowing nebulae would bloom across the darkness, and the familiar quiet of a night sky would give way to a luminous, softly blazing tapestry, a sky filled with more light, more color, more gentle radiance than we have ever known. After the merger, the local group will be dominated by a single giant galaxy. Where once there were two great spirals anchoring opposite sides of the local group, there will be one. Milkomeda will stand as the undisputed gravitational heart of the entire collection of galaxies, a vast, luminous presence around which the smaller members will slowly orbit. The local group will become quieter, more settled, organized around a single great center of light and gravity, like a system finding its final rest. Andromeda's approach has been precisely tracked using Hubble Space Telescope astrometry, Over many years of careful observation, astronomers used the extraordinary precision of the Hubble Space Telescope to measure the tiny, almost imperceptible shift in Andromeda's position against the background of even more distant galaxies. These painstaking measurements, accumulated patiently over years, allowed scientists to map the galaxy's motion through space with a clarity and confidence that simply was not possible before. It is a quiet triumph of patient watching. Hubble measurements confirmed Andromeda has a small sideways motion in addition to its approach. When astronomers analyzed the data carefully, they found that Andromeda is not moving purely straight toward us. There is a gentle sideways component to its motion, a slow lateral drift, almost like a river that curves as it flows. This small transverse movement, though modest in scale, would turn out to carry enormous consequences for how the eventual meeting of these two galaxies will actually unfold billions of years from now. This transverse motion means the collision will be more of a glancing blow than a head-on crash. Because Andromeda carries that small sideways drift, the two galaxies will not simply slam directly into each other. Instead, they will sweep past one another in a long, slow gravitational embrace, more like two great ships passing closely than two objects meeting head-on. The encounter will still be profound and transformative, reshaping both galaxies over billions of years, but it will be a gradual, sweeping dance rather than a sudden impact. The Gaia satellite has refined measurements of Andromeda's motion with great precision. The Gaia Space Observatory, designed to map the positions and motions of stars across the sky with extraordinary accuracy, has also contributed to our understanding of Andromeda's trajectory. Its refined measurements have sharpened the picture of how and when the two galaxies will eventually meet. Each new generation of instruments brings the future into slightly clearer focus, not with urgency, but with the slow, patient accumulation of knowledge across decades of watching. Andromeda was the site of a recorded nova observed by astronomers in 1885. In that year, observers watching the skies noticed a new point of light appearing within the faint smudge of what was then still called the Andromeda Nebula. It brightened noticeably and then faded, drawing attention and careful notes from astronomers of the time. It was catalogued and recorded, a small bright moment preserved in the long history of watching the heavens, its true nature not yet fully understood by those who first saw it. That 1885 event, called S Andromedae, was actually a supernova within the galaxy. At the time, astronomers did not yet know that Andromeda was a separate galaxy lying millions of light-years away. They assumed the event was a relatively nearby nova within our own star system. It was only later, as understanding of cosmic distances grew, that scientists realized what had truly been observed: the catastrophic death of a single massive star, an explosion so enormous it had briefly outshone an entire galaxy of 1 trillion stars from across intergalactic space. S Andromedae was briefly visible to the naked eye at magnitude 5.8. For a short time in 1885, this dying star, located over 2.5 million light-years away, shone brightly enough for a person standing outside on a clear night to see it without any instrument at all. A single stellar explosion, unimaginably distant, crossing all that vast darkness to reach a human eye. It is a humbling thought, and a quietly beautiful one, that something so far away could still, for just a moment, be seen. There is no need to hold on to any of these thoughts. Let them drift past you now, slowly and softly, like stars moving through a long exposure photograph, trailing gently into light and then dissolving. Feel your body growing heavier, your breath moving more slowly, each inhale a little quieter than the last. The universe continues its patient, unhurried turning. Andromeda moves toward us by 110 kilometers every second, and still there is nothing to do, nothing to follow, nothing to hold. Just the soft, still darkness and the slow, easy drift toward sleep. Andromeda hosts roughly one supernova event every few decades on average. Somewhere within that vast spiral, a massive star quietly exhausts the last of its fuel, collapses inward, and then releases an extraordinary burst of light and energy. These events are rare on any human timescale, but across the long, patient life of a galaxy, they are simply part of the natural rhythm. Each one marks the end of a star's long journey and the beginning of something new, elements scattered gently outward into the waiting dark. Variable stars in Andromeda have been used to refine the cosmic distance ladder. The distance ladder is the careful, step-by-step method astronomers use to measure how far away things are across the universe. Each rung of the ladder depends on the one below it, building outward from nearby measurements to more distant ones. Variable stars in Andromeda have served as reliable anchor points on this ladder, helping scientists confirm and sharpen the measurements that underpin our understanding of the size and scale of the entire cosmos. Cepheid variables in Andromeda pulse with periods directly related to their true brightness. These remarkable stars swell and contract in a steady, reliable rhythm, some taking days, others weeks to complete a single cycle. The longer a Cepheid's pulse, the more luminous it truly is. This relationship acts like a natural measuring tape stretched across millions of light years. By watching a Cepheid breathe in and out, astronomers can calculate exactly how bright it must be, and from that, how far away it must lie. Lyra stars in Andromeda's halo help trace its ancient stellar populations. These are old stars, among the earliest generations born in the universe, pulsing with their own quiet, steady rhythm. They gather in the vast, diffuse halo that surrounds Andromeda's bright disk, scattered across an enormous volume of space. By mapping where these ancient stars are found, astronomers can trace the deep history of the galaxy, reading the positions of old stars the way one might read the rings inside a very old and patient tree. Andromeda's metallicity is higher in its inner regions and lower in its outer halo. In astronomy, metallicity refers to the abundance of elements heavier than hydrogen and helium, elements forged inside stars and returned to space when those stars die. The inner regions of Andromeda are rich with these heavier elements, enriched by generations of stars that were born, lived, and ended there. The outer halo, by contrast, holds older and more pristine material, quieter and less processed, still carrying traces of an earlier and simpler universe. This metallicity gradient reveals how Andromeda built itself up over cosmic time. The pattern of heavier elements concentrated toward the center and lighter ones in the outskirts tells a story of growth from the inside out. The core regions were active and star-forming early on, enriching themselves over billions of years. The outer halo grew more slowly, gathering material from smaller galaxies and ancient streams. Reading this chemical map is like reading a diary, each layer holding a quiet record of what came before. The Pan-Andromeda Archaeological Survey mapped stellar populations across the entire galaxy. This ambitious project observed Andromeda across an enormous area of sky, cataloging millions of individual stars in its disk, its satellite galaxies, and its extended halo. The word archaeological is fitting. The survey was in many ways a kind of excavation, digging through layers of stellar history to understand how this great galaxy came to be. It produced one of the most detailed portraits of any galaxy beyond our own. This survey revealed an unexpectedly complex merger history for Andromeda. Scientists had expected to find a relatively smooth and settled galaxy, but the data told a richer and more layered story. Streams of stars, shells of disrupted material, and populations of stars with different ages and compositions all pointed to a history of multiple encounters and absorptions. Andromeda had not grown quietly in isolation. It had gathered and merged and reshaped itself many times over, wearing its complex past in the subtle patterns written across its stars. Andromeda likely had a major merger with another large galaxy roughly 2 billion years ago. Scientists believe that at some point in its deep past, Andromeda encountered and absorbed a galaxy of considerable size, not a small satellite, but a substantial companion. The two great systems would have drawn together slowly over millions of years, their stars and gas intertwining in a long, graceful collision. The evidence of this ancient meeting is still written in the structure of Andromeda today, preserved quietly in the positions and motions of its stars. That ancient merger may explain Andromeda's prominent star-forming ring structure. The ring of new stars sitting roughly 30,000 light-years from Andromeda's center is one of its most striking features, and scientists believe the collision of 2 billion years ago may have sent ripples of compressed gas spreading outward through the disk, much like a stone dropped into still water. Where that wave of compressed material passed, new stars were born. The ring we observe today may be the lasting echo of that long-ago meeting, a circle of light written by a collision the universe has long since forgotten. Let yourself settle now, just a little more deeply. Feel the weight of your body resting gently where you are, each breath slower and softer than the last. There is nothing to hold on to, nothing to figure out. Let your thoughts drift away. Clouds drift across a quiet sky, slowly, without effort, without destination. You are safe, you are still, and the night is holding you gently. Andromeda emits faint radio waves born from the spiraling of energetic electrons through magnetic fields. This process, known as synchrotron radiation, produces a gentle hum of radio energy that spreads outward from the galaxy in invisible, unhurried waves. Radio telescopes on Earth can listen to this quiet emission, translating it into maps of Andromeda's magnetic structure. It is a kind of whisper, a soft, continuous signal crossing more than 2 million light-years of space. At the heart of Andromeda sits a galactic nucleus that is remarkably quiet today. Many large galaxies host active nuclei that blaze with intense energy as their central black holes consume surrounding material, but Andromeda's core is calm and subdued. Its supermassive black hole still resides there, vast and patient, but it is not actively feeding in any dramatic way. The center of Andromeda rests in a kind of deep, ancient stillness. In its distant past, Andromeda may have blazed with the ferocious brilliance of a quasar. Scientists believe that billions of years ago, when its central black hole was actively consuming vast amounts of gas, the nucleus could have shone with a light millions of times brighter than it does today. That era of luminous intensity has long since faded. What remains is the quiet aftermath, a great black hole at rest, the fires of its youth now reduced to the softest of embers. Future generations of telescopes will be able to resolve individual stars across far greater portions of Andromeda than we can today. With instruments not yet built, astronomers will one day map the positions and motions of countless individual stars spread across the galaxy's disk and halo. What we now see as a soft, glowing cloud of light will be rendered in extraordinary detail, star by star, each one a world unto itself, each one a small point of quiet light in the great tapestry. The James Webb Space Telescope is observing Andromeda in infrared detail that was simply not possible before. Its large mirror and extraordinary sensitivity allow it to peer through dust and detect the warm glow of stars in stellar nurseries that were previously hidden. Webb is gathering light from Andromeda that has traveled for over 2.5 million years, and it is capturing that ancient light with a clarity and depth that opens new chapters in our understanding of this neighboring galaxy. Webb observations are already beginning to reveal individual stars in Andromeda's outer disk and halo with remarkable clarity. Stars that were previously blurred together into a general glow are now being separated and studied one by one. In the quieter outer regions of the galaxy, where stars are more spread apart, Webb's vision is particularly powerful. Each resolved star is a small discovery, a single sun far away, now seen clearly for the very first time. Studying Andromeda gives astronomers something rare and precious, a complete outside view of a large spiral galaxy, very similar to our own. From within the Milky Way, we can never step back and see our home galaxy whole. But Andromeda, at its comfortable distance across the local group, can be studied in its entirety, its structure and history laid open to observation. It is, in many ways, a mirror, a way of seeing ourselves from the outside across the gentle gulf of space. Andromeda serves as a benchmark against which astronomers measure and understand galaxies across the entire universe. Because it is close enough to study in extraordinary detail, it provides a reference point, a well-understood example of how a large spiral galaxy is built, how it ages, how it forms stars, and how it evolves. When scientists observe distant galaxies billions of light-years away, the knowledge gathered from Andromeda helps them interpret what they see. It is a quiet anchor in a vast and complex cosmos. When Andromeda and the Milky Way finally merge billions of years from now, life on Earth will not be directly threatened by the collision itself. The spaces between stars are so immeasurably vast that individual stellar encounters will be extraordinarily rare. The galaxies will pass through one another like two great clouds of light, their stars weaving together slowly over millions of years. The merger will be a transformation, not a destruction, a slow and gentle reshaping of two ancient spirals into something entirely new. Long before Andromeda and the Milky Way complete their merger, our own sun will have already transformed into a red giant. In roughly 5 billion years, the sun will exhaust the hydrogen at its core and swell outward, growing hundreds of times its current size. By the time the two galaxies are truly intertwined, the sun as we know it today will be gone, replaced by something vast and dim and cooling. The merger will unfold in a solar system already changed beyond recognition, in a sky already very different from our own. Let your body grow a little heavier now. Let your shoulders settle. Let your hands rest open and still. There is nothing left to hold on to tonight. Each breath comes a little slower, a little softer, carrying you gently downward into quiet. The mind can let its thoughts drift like distant lights, growing dimmer, growing fewer, until there is only warmth and stillness and the soft dark of rest. You are safe. You are held. Let yourself go. Andromeda's great disk is not perfectly flat. It is gently warped and twisted across its span, bending away from a true plane in ways that reveal its long and eventful history. Scientists believe this warping is caused by the gravitational pull of Andromeda's satellite galaxies, tugging and nudging the outer disk over billions of years. Like a blanket softly pulled from two different corners, the disk curves and bows in response. Even the grandest structures in the universe carry the quiet marks of their relationships. The story of Andromeda is, in the end, the story of where we are going, a quiet map of our cosmic neighborhood's own future, written in light and gravity and time. Every observation, every measurement, every careful study of that soft glow in the autumn sky has been a way of understanding our place in something larger and older than we can fully hold in mind. We are not separate from that story. We are woven into it, drifting alongside Andromeda through the same vast and gentle dark. Tonight, let that vastness be a comfort. Let the stars be a lullaby. You are a small and precious part of something immeasurably beautiful, and all of it, every galaxy, every sun, every quiet night, is at rest with you now. Sleep well. Good night.